This is the 2010 FRQ number 4 in the non-calculator section. Let R be the region in the first quadrant bounded by the graph of 2 root x and a horizontal line y equals 6. So this is 2 root x and this is y equals 6. That's the horizontal line. And the y-axis is shown in the figure. Find the area of R. So this one, because it's your equation is y equals 6 and y equals 2 root x, it's a little bit easier to do dx, so you do top minus bottom. So top minus bottom. All right, so the area, part A, R equals the integral between 0 to 9, because that's our x value there, top function minus the bottom function, dx. All right, so let's do our, let's go ahead and take the antiderivative. I got lost for a second there. Our antiderivative is 6x minus 2. This is x to the 1/2, so add 1, x to 3 over 2 times 2 over 3, evaluate 0 to 9. Right, so 6x minus 4 over 3, x to the 3 over 2, 0 to 9. Again, polynomial functions are awesome because we know we don't need to plug in 0, you get 0. So you just plug in a 9. So you get 54 minus 4 over 3. 9 is 3 squared, so 3 squared to the 3 over 2, that makes this 3 to the third, which is 27. 27 divided by 3, that gives me 9. So 54 minus 36, total area of 18. 18 square units. Okay? All right, that's it. Part B says, write but do not evaluate an integral expression that gives the volume of solid generated when R is rotated about the line y equals 7. So here's y equals 7. It's going to rotate this way. So dx is going to be perpendicular. This is a washer method, right? So my big radius, we're not evaluating. So my big radius is going to be the top, which is the axis of rotation, minus the farthest away from me, 2 root x. And my little radius is going to be the top, which is 7, minus the closer function up here, which is y equals 6. So that equals 1. So my volume is going to be pi r squared, pi 0 to 9, 0 to 9, my x values, big radius squared minus little radius squared, and then dx. Okay, that's it. It says write, but do not evaluate. I did evaluate it in my own notebook, but that's just for fun. All right, lastly, region R is a base of a solid for each y where between 0 and 6, the cross-section of solid perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Write, but do not evaluate the integral expression that gives the volume of the solid. Okay, so first things first. Again, it would be really wise to kind of lay it down like so. And this is your region. This is the piece, right? So we want perpendicular to the y-axis. So perpendicular to the y-axis is a rectangle like so. These are the rectangles. So kind of can't see it. Okay. So first of all, it's going up and down y-axis. So it's a dy, the dy function, right? Secondly, my base here. This is the length of this base, right? So the base is trapped between the right function and the left function. So the right function, this is 2 root x. So you got to change this equation. Y equals 2 root x divided by 2. So y over 2 equals root x. Square both sides. So y squared over 4 equals x. That is this same function. All right. And then the right function is 0. So that's really nice. So my base is going to be y squared over 4. Okay. And now it says the rectangle. All right, so rectangle, area of a rectangle is base times height. What do I know? I know my height is 3 times the length of the base. So then my area is really base times 3b, which is really 3b squared. Okay. All right, so the volume of this is to add up all this rectangle, 3 base squared dy, and it's dy, so it's going 0 to 6. And we know my base is y squared over 4. I think that's it. It says write, but do not evaluate. Oh, this one was nice. Okay, that's it.